Okay. Greetings, everyone. This is Group 17, and I would like to present to you our poster presentation. First of all, please allow me to introduce my group members, Irvin Kumar, To Ding Feng, Ng Bin Xian, and me, King Herod Kanzan. All right, I'll start with the abstract. Computing paradigms are essential as they guide computers to perform tasks beyond human capabilities. These methodologies enable machines to help humans achieve desired results and solve problems. Without computing paradigms, computers wouldn't have the necessary blueprints to function effectively in today's technological world. Among these paradigms, the imperative paradigm stands out for offering the most control to programmers. Next up, we have introduction. The imperative paradigm involves writing instructions that change a program state to complete the task. The programmer details how the program should work step by step until it's done. Let's explore how programming develops using the imperative paradigm. Right, we will look at the evolution of programming languages, with C being developed in the 70s, Python in 90s, and the latest one we have Swift, TypeScript, Dart, and Rust. So next up is the architecture. Just like von Neumann's architecture, the imperative paradigm uses a processing unit, a control unit, and memory. The processing unit processes instructions, the control unit directs state changes, and memory holds the computer or program state by storing previous or future states based on the instructions.
So next on, we will move on to the differences between different paradigms. For the imperative paradigm, the programmer specifies specific instructions through code, which he implements into the computer or program. Then the computer or program changes its state according to the instructions received in the form of code. As for declarative paradigm, the programmer or creator specifies the end state or the final state that they desire, and then the framework of the computer or program handles the processes required to achieve that final state. In terms of coding, for imperative paradigm, the changes of the state of the computer or program are based on the instructions given by the programmer in the form of code. Some of the coding languages that can be examples of imperative paradigm are Java, C, Python, and so on, where the programmer codes in a sequence of instructions and the program handles the tasks by changing its state according to the instructions. As for declarative paradigm, the computer carries out the processes based on the framework of itself or the program, based on the end state defined by the user or programmer. Some of the examples of declarative paradigm are CSS, HTML, and one of the most famous ones are SQL. In terms of processing speed and memory, for imperative paradigm, processing speed highly depends on the programmer itself and the efficiency of his code. If the programmer is able to write efficient code, the processing speed will be higher. And imperative paradigm makes use of manual memory manipulation and management. As for declarative paradigm, the processing speed depends on the efficiency of the framework of the computer or program itself. As the user just specifies the end state, the speed highly depends on how the computer or program handles the processes required to reach that state. And declarative paradigm uses automatic memory management. In our point of view, imperative paradigm gives the programmer more control over the outcome and process, but it is more complex. As for declarative paradigm, it gives the programmer or creator less control over the processes and outcome, but it is less complex than the imperative paradigm. As for the main characteristics of the imperative paradigm, the imperative paradigm implements a sequence of statements or instructions in the form of code given by the programmer, and it has a heavy significance on the order of the statements itself, as a change in order will change the final state or desired outcome of the program or computer itself. And imperative paradigm also uses both mutable and immutable data, and it is also divided into two sub-paradigms, which are procedural paradigm and the object-oriented paradigm. One of the examples of procedural paradigm is C programming, and another example for object-oriented paradigm is Java. Next, we will move on to strengths and weaknesses. Paradigm.
So now let's dive into the strength and weaknesses of imperative paradigm. So in terms of strength, for imperative paradigm, it is a conceptual model that is easy to understand as the flow or the sequence is vivid, and the characteristic of the desired state or outcome can be taken into account as the programmer has more control. And is easy to learn as the syntax used is similar and repetitive. In terms of weaknesses, although give more control, the code eventually grow in length and become expensive due to every sequence needing to be specified. And sequence-oriented nature cause future development to become difficult as earlier sequence may need to be modified as well, and larger margin of error when editing as it affect the sequence. So now Ping Xian will explain about the C code. So now I'll pass to Ping Xian.
Okay, so now I'll be explaining more about the coding part. So now if you take a closer look at the imperative programming, as my teammates have mentioned, it can be separated into two sub-paradigms, which is procedural paradigm and also object-oriented paradigm. So for procedural paradigm, an example of it is C programming, where if you can see in our poster, normally in a procedural paradigm, the coding of it will go following the sequence. Means it will go from the top to the bottom, accordingly following the flow. So as you can see, at the beginning of our coding, there'll be header files where we import all the needed libraries, and we have a function prototype where we need to declare in order for us to use the function further on in our coding. And next we have our main function. In our main function is where the actual coding will happens. Where in this main function, we would like to get the sum of two numbers. So we'll declare the variables that is required in the variable declaration part, and then we'll call the predefined function call, which already existed in our library in order for us to use, which is the printf and scanf, in order for the user to input. And then we'll call out the user-defined function, which is add number, that we'll use to add on a number in order for us to calculate the sum. And after that, there will be the necessary printing of the sum so that we can know that what the sum of the number. And if you look at line 20, this is where the definition, where we will define our function, is the function declaration part. And in the function, we declare how we use the variable that we obtain from the user in order to get the sum, which is in line 23. You can see that result equals to a plus b, which is the sum of two numbers that we get from the user. And next, if we proceed to look at the object-oriented paradigm, which is an example used is Java. So in object-oriented paradigm, normally there'll be classes and object, where in this case there are class like square, rectangle, circle, which all of this is an instance of a shape. So it's an example of a shape. So if we look at the geometry class, this is for us to calculate the area of the shape that we might get or might not get. So if we look at the area method, which is the public double area method, where in this method, if the shape that we get is an instance of a square, then we return the area of the square. If the shape is an instance of a circle, then we will return the area of the circle. Then, and last but not least, if it's a rectangle, then we return the area of a rectangle. And this is how object-oriented works, is because that we will know that we need to know that whether the shape is which object in order for us to proceed on with the further calculations or the required code. And that's it for my part. And I think that's all for our presentation for our poster. So thank you everyone for watching, and that's it from us. Thank you.